In this question, part D asks us, determine the maximum height above the ground attained by the block after it leaves the track. So this question is asking us to think about the block after it leaves. And they want us to find this height, we'll call it height final. And that is the highest the block reaches after it leaves the ramp. So for this question, we can go back to the energy rules. We can call this point D, and we can see that the energy at A has to equal the energy at D due to the conservation of energy. So the energy at A, the kinetic energy, plus the potential energy has to equal the kinetic energy at D plus the potential energy at D. As we know, there was no kinetic energy at A, so we have mgh equals, so if we think about it, this has to be 1/2 m, and the velocity at this point. We know that the velocity here, the vc, equals 4.00 meters per second. And we know that when the point reaches its highest point, it will not have a velocity it won't have a y vector for its velocity, simply because it's projectile motion. So there is a constant x force in the velocity that throughout its trajectory it will have this constant velocity because there is no acceleration in the x direction. So in this case, basically, we can say that at the highest point, it's not going to have any velocity in the y, but it will have velocity in the x, and that's simply going to be vc cosine theta. We will know that theta is actually 30, so we can actually replace theta in 30 degrees squared, plus the potential energy, which is actually kind of what we're looking for. So we know that it's m, g, and the h final. We can rearrange this, get rid of all the m's, they cancel. We can say that the h at A minus this whole thing, so minus 1/2 4.00 meters per second times cosine of 30 degrees, all squared, divided by gravity, 9.80 meters per second squared, will give us that final height. If you plug this into your calculator, you will get that h final is equal to 0.70 meters, and that is part D. Part E asks us simply, instead of this ramp being frictionless, what if it did in fact have some friction? And we can quickly do that. Give me a second. Okay. So